Okay, we're going to use the correlated home prices example to illustrate fitting of coupler functions. Okay, so we have input data of monthly data on prices from two cities, Seattle and Las Vegas. Now the prices are not actual prices, but an indexed price with the price of as of January 1st, 2000 indexed at 200 at 100, and relative to that 100, okay, what are the prices starting from January 1990 all the way through 2018. Okay, so now we're going to look at a time series plot of the home prices to see how they are correlated. And we will see that when the prices were low, they were more closely together. So meaning that there was some higher level of correlation, um, not as high a correlation when the prices have gone up. Okay? Now, time series plot of and then we will do monthly change with continuous compounding, which will be like the natural log of the ratio, and we'll plot that and then see how that looks in terms of time series is concerned. Okay, then and we can use data viewer to look at with the monthly change data to understand the relationships. Okay. And then we will model, we're going to fit the probability distribution for monthly change in price in Seattle and then in Las Vegas. And then we can run the simulation as if they are not related, and then we can fit the copular function for the monthly change and then apply that copular function to the probability distribution of price change in Seattle and Las Vegas. Okay, so this is the agenda for this example. Okay, so we have the home prices from January 1st, 1990 to November 1st, 2018 for Seattle and Las Vegas. And remember, these are indexed prices, indexed for 100 for January 1st, 2000. Okay, so we can now do a time series plot. So let's do this, highlight and press enter, insert, and then okay, so let's see that one. Okay, now that's only Seattle. We want to superimpose Las Vegas on it. So let's move this to the top. Okay, so let's format the y-axis to go from 1/1/1990 to November 1, 2018, and for that we have to format axis and enter valid numbers for these. So here the way to get the numbers is you take this date, right, and put it here and change the format to general. So that gives you the numerical value of that date. And then let's take the last one and change that to general. Okay, so now we have the actual numerical value of the dates. Now we'll put 32,874 and then 43,405. Okay, so that gives us the Seattle price change. Okay, so now let's select the graph and change chart design and select data. Now we'll add, all right, series name is Las Vegas, x-axis is the same as before, and y-axis is that, and click OK. I did something wrong. Let's go back in. Select data, Las Vegas. I have x-axis. I have only A2 there. So I need to go A2 all the way through A348. Okay, so now I have it correct. So now we have the two plots. Okay, and let's add titles. So here, of course, we don't need X title because the dates are easily understandable. So this is home price. Let's call it indexed home price. Okay, and then chart title, indexed home price says, okay, January base on January 1st 2000 equal to 100. Okay, and then we'll add a label legend, so that way we'll know what each of the line is supposed to be. So now we have the time series plot, and you can see that the correlation actually is in this area where the prices are relatively low, very close. Okay, when as the prices go up, okay, there are a couple of things happening in the mid range. Okay, about here. Okay, there is a, as the gaps widen, at some point there is a flip in the correlation. So the blue line takes off at about the same rate, but the difference is flipped. Okay, instead of being smaller than red, smaller than Las Vegas, Seattle is more than Las Vegas. So there is a complex relationship in terms of how these two prices are related, and you can be sure that they are related. It's not that they are all over the place. They are related, but it is more complex than a simple correlation.